Let me ask you something. Why does Instagram load your profile almost instantly, but some university portals take 8 to 10 seconds? It's not magic, it's not just better servers, it's caching. Today, we're going to understand how caching makes system fast, scalable, and production ready. We'll cover multi-level caching, write-through and write-back, cache invalidation strategies, and a real-world example using user profiles and a leaderboard data. Let's break it down. So, what is caching? Caching is simply storing frequently accessed data in a faster storage layer, usually memory, so we don't hit the database every time. Normally, a request looks like this. A user to application to database to response. But databases are slower than memory, so we do user to application to cache to response. The database is only accessed if the cache misses. This reduces latency, database load, infrastructure cost, and improves scalability, speed, and user experience. So, why is caching critical at scale? Imagine you have 500,000 users. Each user opens their profile 5 times a day. That's about 2.5 million database queries just for profiles. Now imagine 5 million users. Without caching, your database becomes the bottleneck. With caching, first request loads from the database and all subsequent requests load from memory. That's the difference between a system that survives and a system that crashes under traffic. Now let's talk about something very important. What happens when data changes? For example, user updates their profile picture. How do you update the cache? There are 2 major strategies. First, write-through. When the data is updated, we update the cache and the database at the same time. The advantages are that the cache and database stay consistent, and it is simple to reason about. The disadvantage is that it has slightly slower writes. Second, write back, also called write behind. Here, the application updates the cache first. Database is updated asynchronously later. The advantage is that it has very fast writes, and it is great for high throughput systems. The disadvantage is that there is a risk of data loss if crashes before database update, and it is more complex. So here's the engineering trade-off: consistency versus performance. Financial systems usually prefer write-through, while high-performance analytics systems might prefer write-back. Well, there's a famous joke in computer science. There are only 2 hard problems: cache invalidation and naming things. Why? Because cache data becomes stale. If a user updates their name, but the old name stays in cache, that's a bad user experience. There are common invalidation strategies. First, TTL, time to live. We can set expiration time. After 10 minutes, cache refreshes. Simple, but not always precise. Second, event-based invalidation. Whenever data changes, we immediately update or remove the cache entry. More accurate, but more complex. Poor invalidation design can cause inconsistent data, stale views, and confuse users. Now let's take a practical example. Imagine we're building a quiz competition system. Profiles are read frequently but updated rarely, so we cache profile data. When a user edits their profile, we invalidate only that specific user's cache. Now, leaderboard. Leaderboard is accessed constantly, but scores change often. Option 1 is that we can cache leaderboard and refresh every 30 seconds. Option 2 is that we can update the leaderboard cache every time a score changes. But here's the challenge. If the cache refreshes too slowly, users can see wrong rankings. If it refreshes too frequently, you lose the performance benefit. So caching strategy depends on read frequency, write frequency, and consistency requirements. So today, we learned caching is not just about speed, it's about scalability. Multi-level caching reduces database pressure. Write-through prioritizes consistency while write-back prioritizes performance. Cache invalidation is critical. If you design caching properly, your system scales smoothly. If you design it poorly, you create subtle, hard-to-debug issues. So in the next video, we'll talk about database sharding and how to scale beyond a single database. Thank you and see you in the next video.